everyone, we're going to use medians and altitudes for triangles. This is definitions and examples and theorems. It's more informational type video, and we're going to talk about the difference between medians and altitudes. So here's our vocabulary. The median of a triangle is a segment from the vertex to the midpoint of the opposite side. So we can have some triangle and the median would be some point, that would be like a median. All right. The centroid is the point of concurrency of the three medians of the triangle. So if we did three things like that, then that's the centroid right here. So these two go together. A centroid always goes with the median. Orthocenter goes with the altitude. Now, the difference with the altitude is it's perpendicular. This one doesn't have to be perpendicular, but or this one's not really perpendicular. So if you draw the altitude, then it's going to be perpendicular. So that's the difference between these two. And the orthocenter, which goes with altitude, is the point at which the lines intersecting the three altitudes of a triangle intersect. So this would be something like this. Something like that. All right, so that would be the orthocenter. And here's your theorem, concurrency of the medians. So basically, let's look at this. I'm going to erase this. All right, the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So, for example, let's see what they're doing. AP is 2/3 of AE. That just means whatever you get here, this would be 2/3 and this would be 1/3. And then you can do BP is 2/3, and then this part right here would be 1/3. And the same thing for this one. This is 2/3 of the length, the whole length. So this part would be 1/3. Okay. So we have a centroid. That means we're talking about medians, nothing to do with perpendicular. So basically we have GM, and it is the total length here. So you'd have 6 equals 2/3 based off our theorem, GL. And to solve for GL, then you would multiply both sides by 3/2. I'll just do both sides, 3/2. So this cancels that out. So 2 goes into 6 3 times, and 3 times 3 is 9. So the whole length is 9, so that would mean this part is 3. Because 9 minus 6 equals 3. All right, let's do this example. Suppose FM is 10. So this is 10. And we got to find MK and the total length. So we know that FM equals 2/3 of FK. So basically what I'm saying is this length is 2/3 of this whole piece here. So we know FM is 10 equals 2/3 of FK. So again, multiply both sides by 3/2. Multiplying by the reciprocal, 2 goes into 5, 5 times, so 5 times 3 is 15 equals FK. So for FK, then all you take is your 15 minus your 10, and that gives you your 5. So remember, if this is 10, then this is 5. This is 2/3 part. This is 1/3 part. All right. Finding the centroid of a triangle. Let's see. So basically, the first thing we're going to do is, since these points lie on the same line, we can find the midpoint. Oh, we got to find the midpoint of this line first. So we're going to find the midpoint, and you just use your midpoint formula. So this would give you 4, 3. All right. The centroid is 2/3 of the distance from each vertex to the midpoint. So basically for M, we're going to do as M equals 6 minus 3. Right? Because 6 minus 3 gives you the 3. All right, so the centroid is going to be 2/3 of, and what we're looking at is this whole length is 3. So 2/3 of 3 equals 2. So basically, you're going from K down 2. So this is 2, and this is going to be 1. And then you get the coordinates of the centroid for P as 4, 4. So basically, that's it. And here we're going to talk about altitudes now. Now, altitudes have to do with perpendicular lines. So the lines containing the altitudes of a triangle are congruent. So the lines containing AF, BE, and CD all meet at G. So you can extend this and they meet at G. So we have to find the orthocenter in the triangle. And basically, we're just drawing it. So for this one, we want to draw it perpendicular. So put the point here and draw it here. So remember, these are both going to be altitude. Those are the legs. And then for the orthocenter here, you're going to draw down, get a right angle, and then draw straight down here to get a right angle, and then do it again this way. So there's the picture. And finally, we have a proof here, and you can read it and absorb it, but I'll read it through. We have BD is the median. Oh, we're going to prove that the altitude to the base of an isosceles triangle is also a median. So this part is given. This is the altitude to the base. It's the altitude because it's perpendicular there. So we want to prove it's the median. So we know the legs, AB and CD, where's AB and CD of the triangle congruent, because right angles are congruent. So these two angles are congruent. So these two sides are the same. Because BD is the altitude to AC. We also know that by the reflexive property, this line's congruent. So since we have a right triangle, by the hypotenuse-leg congruence theorem, we know that the two triangles are congruent. Because all you need is a hypotenuse and one leg. All right? So since they're congruent, all the sides and angles are congruent because corresponding parts of congruent triangles are congruent. So that means D is the midpoint because by definition these two sides are congruent. Therefore, BD intersects AC at the midpoint, which is the definition of a median. And this part is the kind of like a fallout from this proof. So you can look at that if you want. But it's just saying that it's also a bisector of this angle here. So just you can take a look at that. And that's it. Thank you. Have a nice day. Bye-bye.